Thank you for replying to Ethan's email. He was telling us about it. Yeah. Very helpful for us.
That is awards. All right, it's 11:10. I did not solve it. I'll do it later. People can join. So, like, if you go on Discord, you can play against everyone else. I see. Yeah, some people solved it. Okay, all right. So, hi. So, what we're doing today is basically continuing talking about the basic semantics of C. So, hello. So I wanted to first just write a small program in C. We already did like a hello world, just to give you the kind of flavor that you would have gotten if we had done labs in the first week. It's just that it's not like the timing this year wasn't really working for that. So we'll start labs next week. So again, kind of it's so this is what the basic hello world looks like. I was asked to do it in light mode, so it's now in light mode. So that's the hello world. The hello world comes from here. You can have like a loop. So if you remember, we defined variables like this. So if I want an array, can define an array like this, and maybe I'll define it as like whatever, 6, 7, 8, or maybe just 6, 7. And if I want to, for example, loop through the array, I can. That would look like this. I'll explain the syntax in a bit. The point here, of course, is not the syntax. You'll get used to it very fast once you start writing in the lab. The point is just show you what those things look like, and then we'll go back and talk about what they mean, which is the harder part. So here, what I'll do is I'll just print out the elements of the array, and that's going to look like this. So two things to notice here. So one is this is kind of the standard for loop in C. So this would be equivalent to something like for I in range 0 to in Python, except the way it works is you say I starts with 0, you say go until I stops being smaller than 2. And I++ means increment I by 1 every time. So you could, in fact, write it as I plus equals 1. That also works. And that would be the closer thing to Python. In C, I plus equals 1 is the same as I++. More or less. There's like a subtlety about what I++ does exactly, which we'll get to later. But for the purposes of this is the same. I could have said I plus equals 1. That would have worked. Usually people say I++. So this is kind of like the for I in range 2. And then here I'm printing. So the way we print is with printf. So in C, you have to specify what kind of value it is that you're printing. So in this case, array at I would be an integer. So the 6 and the 7. The %d corresponds to the fact that you're printing a decimal integer. So that's why that is what will be printed. The new line, same as in Python. You first supply the format string, and then array I gets substituted in instead of the %. Another thing you'll notice is in Python, I just go for I in range 0, 2 without a worry in the world. In C, you need to say what I is. So say, in technical terms, is declare. So before I use any variable, in fact, here you could declare it just right there. But like here, I'm going to use I. So I need to say int I in order to say that the I that I'm going to be assigning here, where say I equals 0, is an integer. So before you use the variable, it has to have assigned, has to have had assigned a type. And in this, and that only happens once. And this happened here when I said int I. That happened here when I said that array is an R rather is an array of integers. The way I indicated it is by saying it's of type int with the square brackets. That means it's an array of integers. Ordinarily, if you initialize it, then you would probably not say it's of size 2, just because that's superfluous. You could say that. That is also legal. If you don't initialize it, you could say something like int array2 with 10. That would be like this. Okay, so it's just that when you're initializing it, it's implicit that you said it's 2 elements, so it's of size 2. Otherwise, you declare it like this, and the int and the square brackets indicate that it's an array. All right. What else do we see? So there is semicolons everywhere. So after every statement, there needs to be a semicolon. If there isn't a semicolon, what's going to happen is you try to run it, and you'll get a compilation error. So it'll just say invalid syntax. And the invalid syntax here is it tries to read this part, and it says that makes no sense. because that's not a valid instruction, like int array 10 int I, that's not the thing. So need to punctuate. Another thing that you notice is that we have the curly braces. Curly braces, in fact, if you see other code, are optional if you just have the one line under the for. So you could, in principle, leave them out. I usually don't. Where you place them is also a matter of style. So ordinarily, the way I to follow what's called Kernighan and Ritchie notation, which style rather, which is that when I'm defining a function, the curly braces go like this. So on the line after the function signature. On the other hand, for loops, while loops, stuff like that, the curly braces go like this. C doesn't care. You can do whatever you want. So this is also fine. Okay, so C doesn't care about white space. It's just a matter of style and being kind of consistent and nice about it. All right. So that's kind of like this. Question so far? So like an example of what that looks like. Yeah. Yeah. Yeah, that's a good question. So if you don't so by default, if you don't initialize something, then the value could be whatever. So a lot of and that's kind of a common source of bugs, is trying to access values that are not initialized. So a lot of the time, I'll try it here. A lot of the time, it will happen to be 0, but it doesn't have to be 0. It could be anything. I'll try to make it so that it's not 0. So I'll print the I, which is not initialized, similarly to how array to 10 elements is not initialized, and we'll see what happens. I'm just doing like Control S. Yeah. All right. Yeah, and it wasn't in fact initialized to anything in particular. So the value of the I was 32,765. So that is what happens. So you do want to initialize. So a good compiler will actually give you a warning if you try to do it. If you try to print something that's not initialized, and therefore the output could be anything. So that's kind of a very common source of bugs, is to, on some computers, it would happen to be 0 just because there was like a 0 lying around there before, and then it works fine. And then on another computer, or you restart your computer and it stops working because you were relying on the initial value being something that you didn't specify. All right, good question. Other questions? Yeah.
As a variable and that variable, would it print the same number each time, even though it initializes or would it print a different?
Okay, yeah, that's a good question. So the semantics of the for loop are like this. So the answer is no. So this would be if I say like I think what you're saying is like element this, and then I print I and I print array I, and the question is what I is going to be.
It's a different variable in the for loop, and you try and print that without like assigning it.
Oh, I see. So like if I say like int A, and then I print, so no. So you're asking like, so if I do it within the same program, once it's there, it's there. So like every time I print the A here, it is going to have the same value. Across different runs, it might be different. So let me just do that. So I'll do like I equals over here. And I'll do a new line here. This is a good question. So so A is this, and print A. So hopefully across different runs, we'll see how it's different. So here, well, okay, it's not quite. Oh, I think it was different across different runs. Yeah, it was like 30,000, but something else. Yeah, but A is the same because once the A is defined, it doesn't matter that. So in the second iteration, it's not like it gets redefined. It's already there. So I think that was your question. On the other hand, yeah, like across different runs. Wait, try it again. that will be different. So that's what happens when values are not initialized. Right. Yeah, so that's a good question because it might, so kind of to explain, because I did not quite hear the question right the first time, and it's a really good question. So it looks here like, are you like placing a new A every time when you're running the loop? And the answer is no. The answer is what really happens is this A is going to be assigned when the function starts running, actually. It's just that it's not going to be accessible outside of the for loop. But it actually gets like pre-decided when the function runs the first time. In fact, before the for loop. Okay. All right. So that's like that. Other questions? All right. So let's just quickly, I'll have you do something else in the lab as well next week, but just quickly to do something that's slightly more complicated, I'll write whatever bubble sort. Just like practice. So here is where kind of C gets complicated. What you'll see is I'll write something that's very much like Python that will happen to work because I know what I'm doing, but I'll show you kind of where the translation to Python starts maybe getting dicey from Python. So I'll just have an array, and I'll say that I want the array to be an input to the function. So the way I define the function is this is the function name. This is the type of the value that the function is returning. Void just means it doesn't return anything. And this is what the function takes. So just like with declaring variables, I need to specify what type of variable the function takes in. So in this case, it would take what looks like an array of ints. In fact, it's not. We'll see what it is exactly later. And it also needs to take the size. And the reason it needs to take size is that this is not actually an array, and finding out the size of the array in C is a whole thing, which you can't always do. We'll see the details later. So after I have my array and my size, there is kind of nothing much to worry about. I'll just write the normal bubble sort. So I'll define I and j. And I'll say, okay, so for I equals 0, I smaller than size, I plus plus. Again, think of it as for I in range size, basically. So like that's the same kind of thing. And now I'll say for j, 0, j smaller than size minus I guess, j plus plus. And now we just need to swap the neighboring values inside of array. C does not have the kind of swap that Python does. You can write a swap function, which we'll do later, but there is no kind of simultaneous assignment thing that you can do. So just need to do it manually. So we'll say have a temporary value that I'll store things when I swap. Say if array at j is larger than array at j plus 1, then we got to swap them. So in C, unlike in Python, the parentheses and the if are mandatory. So I swap them. So I'll say temp is array j plus 1. And I'll say array j plus 1 is array j. And I'll say array j is temp. And I'll keep going. So here I have a small bug. So here I go up to j equals size -1 initially. That means that I would not be allowed to try array j plus 1. So that would be -1. Make sense? So the only additional difference from Python is that we don't have a convenient swap. So in order to do the swap, I had to do the temporary variable. In order to have the temporary variable, I had to say that it's, an int type. Make sense? Okay, let me try. So I'll run it. I did not call bubble sort, so nothing is supposed to happen. But the fact that it didn't complain means that it compiled. So it translated the C code into machine code. It's just that all of that was not really relevant. So I'll now try to sort something here. So I'll say array 2 is 6767. And I'll do bubble sorts array 2. And so for now, let me just try to run it. I forgot to say that this is an array of size 4. Okay, it ran, so that's good news. So I now need to print it. So to print an array, there is no printf array thing. You have to do a loop and print the elements one by one. So let me just quickly do it. So here, I'm just going to do a for loop and print every element in turn. And of course, here, it's not any kind of array. It's an integer array. So I know that I'm printing integers. So I'll print it like this, and I'll say array at I, and I'll put a semicolon. And that's my print array. So here, I think I called my bubble sort, and now I can call print array. And again, I supply the size, and I run it. And I forgot, I did not print a new line at the end here. So let's be nice about it. So I printed a comma after every one. So I'll print, yeah. So I'm doing like the last element and a new line, I guess. Well, I guess the new line would be unconditional. So this would be array size -1. And I'll print a new line at the end, whether or not I printed the last element. It's the problem. Printf. So the F stands for formatted. So this is called the format string. And here is my sorted 6767. All right. Questions about this? So we have bubble sort and we have print array. Right. So again, like you'll get used to it. I'm just for now pointing out the differences. Technically I told you all the syntax. I think kind of once you do it for an hour or two in the lab next week, you'll get used to the basics of it. So the really difficult parts, so this is the kind of thing that people still get tripped up on the midterm, is, for example, in C, there is no way to find out how many elements there are in this guy at all. Y we'll see later. So you got to pass the size, stuff like that. Okay. Other than that, it's just like a one-to-one translation of what we've been doing so far anyways. All right. So that's like this. So again, back to the semantics and eventually to why it is that you need to pass the size. So variable declaration, that's something that we've seen last time. You have various different types. So we saw ints, we saw arrays, that's gonna come up in the next slide. We also have, great. We also have variables that are of type address. So here, S is of type address. It's a special number. And the type here is char star. If you remember from last time, you can initialize a variable whose name is PC and whose type is char star like this. So you can say, I want PC, so the variable that's of type char star, to be the address of where C is. Okay. So arrays are like this. We just discussed them at length. So here's more details about pointers. So this is the syntax that we saw before. So you say int A is 42. Okay, that's the usual thing. You now say the variable PA is going to have the address of A. So here, that's the same kind of thing. So S is the same kind of thing as PA. They're both addresses. It's just that when you initialize with a string literal, what happens is ABC gets stored somewhere, and then S is actually the address of where A is. You can go and change the value at an address. So I can say, for example, star PA is equal to 43. So PA is the address where A is. So star PA equals 43 is put 43 in the address PA, which means put 43 into A. So let's do that on the memory table diagram. So this is linked and you can hopefully open it. Let me know if you can't, because sometimes the sharing doesn't work for some reason. I don't know. Okay, evidently people can open it. That's good. Make a copy. So here's what's going on in the slides over here. All right. So when I say int A equals 42 and char S is ABC, here's approximately the kind of thing that happens in memory. So in C, unlike in Python, there is no like separate variable table and a separate memory table. It's all the memory table. So how do I know what is where? Well, the program keeps track of it. So for example, the program might decide that this is going to be where A is. And it might decide that this is where the S is going to be. If you remember, there was an S. Let me just... Okay, so it might decide, okay, so the A is going to be over here, the S is going to be over here, and then we also have a PA, and maybe the PA is over here. And then the effect of saying A is equal to 42 is, well, A lives at 1032, so that means put 42 over here. And then PA, which lives over here, we're saying PA is address of A. So address of A is 1032. That's what it means. So that means that here we're going to put 1032. And when we're saying car S is ABC, well, the ABC has to go somewhere in the same way that. So I'm going to cheat a little bit and do it kind of like this, which is not quite how it works in C. But the ABC is somewhere. And then when you say S is ABC, S is going to be 1060. When I say star PA is 43, what I'm saying is go to address 1032 and at address 1032, make this be a 43. So I usually don't think about this way. The way I think about it is, well, like what can I do with PA? The only thing I can do is I can print its value or I can use this value in order to store the value in A. So I just think of star PA as A. Makes sense? Yeah. So the type, so the answer is the type can be slightly different. In general, you should keep the types be the same. So technically, I tried to simplify it a little bit. And by simplifying it a little bit, actually the type of ABC, like it said in the slide, is const car star. It's not car star. So the answer is it can be a little bit different. Or maybe you're asking like, can like the type of 43 be different? The answer is, again, it can be like, so you can assign an int to a float, stuff like that. There is sometimes automatic conversion, but in general, they should match. Okay, yeah.
If you didn't have the star with P underscore A, would that do anything? Or?
Yeah, that's a good question. So what would happen if I just said PA equals 43? The answer is that would give me an error because the types don't match. I could force it. But 43 is not a valid address. So like technically saying PA equals 43. So like this is this kind of thing where I say PA is equal to something, right? So if what's on the right-hand side is a valid address, you can do it. So the example that I would give is something like this. So I could say int B, and then I would say int B, and then I would say int PB is address of B. And then I could say PB is address of D. So that's the example. And that's the same thing, right? So it's just that the first time that you define PB, you have to declare it, you have to say what the type is. But this part and this part, they're the same. So you ask what would happen if I said like 43 here rather than address of D, and the answer is type mismatch, so it would give you an error. But really what you're asking is something like this. And the answer is you can totally do it. Like, so it used to be that PB was the address of B, and now PB is the address of D. And if I say PB equals to 50, that means that D is also 50. Make sense? So this shouldn't be, so I'm trying to answer questions. I also have a story that I'm telling. It's not an easy topic. We're gonna spend a couple weeks kind of trying to get our heads around it fully. So this is kind of the first pass. But yeah, questions so far? Okay, so the other part of the story that they did not yet get to is here you have car S is car S is ABC. So now S is 1060. So the way that so far we had to use it was to use printf with %s, which specifically takes an address of the first element of a string, if you want to think about it as a string. Here, like we said last time, was a nullity. Okay. So that's the overview. So that's like that. I now want to switch to functions because that's kind of an easy access point to doing a little bit of pointers. So functions work like this. So if I want to add, so this is an addition function. So this is the return type. So it was void in the sorting function. Here it's int because we are returning a plus b, which is of type int. And here is the list of parameters. So same as in Python, except you have to specify the type of each input. Okay, so that's the easy one. So here's what happens if you combine functions and pointers. So if I pass PA to F, I can then go to PA and change its value. So let's do that. So basically, let me first do kind of the obvious thing without the function. So I'll say A is equal to 42, and I'll say int PA is address of A. And then I say star PA is 43. So that makes it so that the value of A is now 43. Okay, and that's because PA is the address of A, and here I'm saying go to the address of A and put the value 43 there. Is that good with everyone? So you can kind of think about it as saying, if I say star address A, and in fact you can do that, so you can kind of think about it like that, that the star kind of cancels out the address of. Does that make sense? So just because this is saying get me the address of A, and this says go to the address of A, so this is just A. All right. So now I want to talk about the semantics of functions here. So this is change A from the slides. This is like this. And this is saying PA is equal to 43. So I can, instead of doing this, say change A address of A. So what happens here is we take address of A, we put it in PA. So it's the same as this kind of deal, except we take this and we copy it to PA. So that's the same as assignment, same as in Python. Then inside the function, I can say star PA is equal to 43. And what that does is exactly this. So that means go to A and change its value to 43. So the result is that if I do that and then I print A, that would print Oh, I didn't select a language. That would print 43. Okay. This is in contrast to, don't change A. Which is this, which works exactly the same as what you would expect. Well, I mean, you wouldn't see it, but if I call don't change A over here, that doesn't matter. A is still 43. Right? And the logic is the same as the logic in Python. When you have a local variable, you change the local variable. That only matters inside the function. It's a local variable anyways. Exactly the same as in Python. Here, PA is a local variable, exactly the same as in Python, but you're not changing PA, you're changing the value at the address PA. So for that reason, that has an effect outside the function. So the way to see it is you can say PA is equal to 0 over here. 0 is a special value which you can assign. It's not a valid address, but it's not going to produce an error. And that doesn't matter to anything. It still compiles, it's still 40. Make sense? So this, if I take you back to Python, is equivalent to this kind of thing, right? So if I want a change A, what I want is for A to basically be a list, right? So if I say A at 0 is equal to 43, I'll have a main function. Why not? I'll just call it here, right? So I'll have a main function and I'll have A equals 42, and then I'll change A like so. And if I print A, then A will be the list with the contents 43, right? Is everyone with me? Does that make sense? And the logic for Y is exactly the same. The logic is, yes, the A here is a local variable, but what I'm doing is I'm going to the memory table and I'm modifying the contents. In Python, there is no way to modify the contents of an integer. But in C there is, so it's not a problem. Okay, so this is the equivalent to the change A. The equivalent to don't change A is, of course, A equals 43. Right? So it's not because it's an integer or a list. It's because it's whether I'm changing the memory table or not. So here I'm changing the memory table, like you hopefully remember from last time. Here, in the same way, I'm giving it a way to change the memory table by giving it the address of A. And then inside of change A, I say, go to the memory table and change the value to 42. Make sense? So, okay. So why am I bringing this up right now seems kind of in the weeds. The reason is that arrays and pointers are very closely intertwined in C. So once you start dealing with arrays, you're actually dealing with pointers. So in C, even when it looks like you're saying A at 0, really what you're saying is this. where A gets converted to the address of the first element of the array. And you're then going to the address A plus 0. In the same way, A at 1 is the same as star A plus 1. And that would be the second element of A. Okay, so what happens in C, and that is going to become important in a second, is A at 0 is not really A at 0. A at 0 is really compute an address. So here A plus 0 is just A. So get me the address of the first element, and then get me the value at that address. This is saying get me the address that's the address after the first address, and then get me the value there. Okay. So why is that important? I have 8 minutes, so I'll just tell you why it's important, and I'll do an example, and then we'll stop. So it's important because what happens here is we just passed we passed what looked like an array. Really, it was the address of the first element of the array. And then what we're doing here actually changed the array, right? So here I kind of wasn't worried about is array a local variable or anything. And R is a local variable, but what I'm doing here all the time is doing stuff like array at j is equal to temp. So that means that this will have an effect outside the function, because what I'm doing is I'm going into memory and I'm saying change in memory what array j is. What I'm sending to the function bubble sort, for example, is just the address of the first element of the array. Right? So every time I say array j equals temp, array j plus 1 equals anything, that changes the memory. That has an effect outside the function. So let me do a small example. So we had the problem before where we didn't have convenient syntax for swapping elements. This is not the only way to do it in C, but it is a way. So one thing that I can do is I can say, okay, I cannot obviously have a swap function that takes int A and int B. It doesn't matter what I do in the swap function. It's not going to have an effect or anything, because all I have is the value of A and the value of B. That's not going to affect anything outside the function. However, if I send the address of A and the address of B, then that's now cool. I can now change the values at address PA and at address PB. So I can say I'll have a temporary variable. Again, have to have that at some point. But once I have it, I can say, okay, so temp is whatever, star PA. So now star PA can be star PB. And star PB can be temp. And now I have a swap function. So X will be maybe 42, 43. And I can say swap. So the types have to match. I have to send the address of A to PA. So PA is of type and star. So I'm saying PA is equal to the address of A. I'm saying PB, I intentionally made it X rather than B because the names don't matter. That's going to be the address of X. And now we print. I print A and X. That prints 43, 42. So that did change the values. Does the logic here make sense to everyone? Questions? All right. So let's do it with arrays as well. So let's say that I have an array. Right? So let's say that they want to swap So I can do it using the same kind of syntax. So I'll just say swap, and then I'll say address of array at 0 and address of array at 1. I don't have my print array here, so I'll just print them separately. So that's like this. Does that make sense? So same logic. I'm just saying I'm giving you two addresses, the address of where whatever this guy is and the address of whatever this guy is. Swap the values there. That's what the swap function does. Right? I can also actually do it like this. So what I said is when I say R and C, what happens is this is actually just address of array 0. And when I say this is the address of the second element, or element number 1. So this and this are actually the same. And that's because, if you remember from the slides, array at 0 is just star array plus 0. So just star array. Right? So address of array at 0 is address of star array is array, like in a way, because you can think of the ampersand and the asterisk cancel each other out, right? Because the ampersand means address of, the asterisk means go to that address. So you cannot do it with an integer because this doesn't make sense. If array were an integer, you cannot say go to this whatever integer or character or whatever. So asterisk has to be followed by something that's an actual address. But whether you do star ampersand or ampersand star, if it actually makes sense, they cancel each other out. All right. So that means that instead of saying address of array at 0, I could just say swap array plus 1, and that would also work. And we can see that if I do this again, this will print 6, 7 again, because I swapped the 7, 6 back. So it's now 6, 7, 6, 7. Okay, all right, 12 o'clock. I will see you tomorrow. Bye. Yeah, so some people have lab on Monday, some on Wednesday. There's no labs this week. Labs start next week.
Like a star with the temp variable. Like P of A and PB, they all have like you're using the star.
Well, so So they do because PA it has to do with the type, right? So PA is of type in star. So if I want to have an integer on the left-hand side, this is an address of integer, this is the integer.
So temp doesn't need to be a type in star.
Well, in fact, it cannot be if I want this value in, right? So I could say I want to swap the values of like PA and PB rather than the values at PA, PB, and then temp would be a 5-star, and that would be a whole different thing. But because what I actually want is reassign integers, I want to have a temporary space to store the integer and then store.
Okay.
Yeah.
If I have int a equals 42 and I go star a or actually oh I mean like if I had this as like at,
Yeah.
like int a equals at and then I do
Well, you can kind of have that. So int A has to be a number.
okay, if it was I had star a equals at and like go a equals 33 is that
You cannot, so first of all, A and PA are not by default connected. Those are just names, right? So if you say PA is equal to address of A. Right, so like here somewhere, so you can have that's like that, right? So like here C is C is the at sign, and then like PC is address of C, right? So that's a lot, and then you can say star PC is equal to a new character. That you can do. I think you're so you can like you can do it in the same way that you can assign an integer to a float. So it does have kind of this kind of automatic conversion, but there's like two things going on here that are separate. So one is like the pointer stuff, and one is the type, and one is kind of implicit value conversion. So you can implicitly convert a float to an int. So you can say an int to a float rather. So you can say like float x is equal to 5 without the decimal, right? So that's a lot, right? So that's one thing. And actually in the same way, yes, you can assign an integer to a car that is actually kind of allowed, but that's separate from the addresses, if that makes sense. Yeah. Okay. Yeah. So, yeah. So, okay, so here it's simple. So just switch to the terminal tab. So, yeah. Yeah, it's not the reason I asked for the laptop is it's not that simple on all computers, unfortunately. But for you, it's just it's just in the terminal. Yeah. Yeah.
Yes.
Alright.
Addresses and integers are different types, but we can do integer addition to addresses, like when we did array plus one.
So yes, I'm evidently yes. So it doesn't work the other way. But so you cannot add a pointer to an integer, or you can, but it's gonna be a pointer. But yeah, yeah. But an address like it is. So what it is underneath is an address is just a long integer. So if you remember like the long int, so in practice, that's how it's implemented. But C wants the flexibility of deciding to do it somehow differently. So there's rules about you're allowed to add integers to addresses because that always makes sense. But it's still kind of separate types.
Right, okay, thanks a lot.
Yeah. Yeah, right.